So hello everyone. Let's start my timer. So I'm Hervé Bredin, and this is the task was organized was co-organized with my two colleagues Camille, Guinaudeau, and Claude Barras. So this is about multimodal person discovery in TV broadcast. So the motivations are simple. I needed to make it quick. So the idea is that huge TV archives are useless when you cannot search them. It's obvious. And the other thing is that people love people. They want to look for other people in this huge corpus. So we need for person-based indexes. So the task was defined like that. So for each shot in a collection of videos, you had to provide the names of the people who can be both seen as well as heard in the shot. So in this example here, in the first shot, you were not supposed to return A, because person A is not actually talking, only his face is visible, so the expected output was person A for shot 2, person B for shot 3, and person A and B for shot 4, because both of them are speaking and appearing at the same time. So the list of people you are supposed to look for is not known a priori, and therefore you cannot use prior biometric models to recognize them. The only way to recognize them is by finding their names either in the text overlay, like in shot 1, where the name of this person is written on screen just below his face, or in the speech transcripts themselves. So for instance, in shot number 2, this guy is pronouncing the name of the lady just after. So this is the only way in this example to recognize, to find the identity of Mrs. B. So no biometric models allowed. So obviously this is a very multimodal task because you have to do all kind of stuff to answer this question. And so to help participants get started, we provided a whole set of modules, baseline modules. So it includes face tracking and face clustering, optical character recognition in videos, followed by name detection in this text, because any kind of text can be written on screen, so you had to filter out the names. We provided speaker diarization result as well. For those of you who don't know, it's the equivalent of face tracking and clustering, but for speech. So you, basically it answers the question, who speaks when, but anonymously, you don't have the actual identity of the speakers. And then we also provided the output of automatic speech transcription systems and name detection on top of those ASR output. And also, we provided 3 different fusion modules that would combine all those systems differently. So the first baseline was what I call here the audio baseline. It's not completely fully audio, but basically it relies on speaker diarization and then on the propagation of the names that were detected in the video to the speaker clusters. The video baseline is the equivalent but for face, so we first do face clustering and then we try to name each face cluster based on the detected overlay names. And the audio-visual baseline is the temporal intersection of both, because you have to remember that we are supposed to answer the question to tag only the people who both speak and are visible at the same time. The motivation behind that was we suppose that these are the person of interest in the corpus. If they're just in the background not speaking, they are not really interesting to the user. Okay, so the dataset this year was much more diverse than last year. So this year we had 3 subsets, one from INA, in French, coming from 2 TV channels, France 2 and France 5. It's about 90 hours of video corresponding to 63K shots. The second corpus was coming from Deutsche Welle and was provided by the UMC project. So it contains videos in German and English, coming from 2 Deutsche Welle websites, Euromax and Deutsche Welle News. It represents 50 hours, where you get the numbers. And then the last one was provided by UPC. It's a Catalan corpus it's a smaller one, but it was fun to have it, to make it even more diverse. So how did we evaluate the runs? So basically the participants were asked to submit their runs in this kind of format. So basically an ID for a shot, the name of the person that they managed to detect, and a confidence score. So they were asked to provide names in this format whenever possible, because then we actually queried the outputs of the participants using queries formatted like that. First name underscore last name. No accent, so just A to Z letters and one underscore in the middle. And so, given a query, the shots were sorted by the edit distance to the query, and then by confidence score. And we used a regular information retrieval metric to evaluate them. Here, the mean average precision at 10. So I won't be long on this aspect, but because I'm going to give a short presentation as well tomorrow on this part, but basically participants had access to a submission webpage where they could submit one primary run and 4 contrastive runs. So for the 4 contrastive run, they could use biometric models if they wanted, they could use external metadata if they wanted, but for the primary run, they only could use the actual test set to recognize the person. No external data, no biometric models, etc. We also provided a collaborative annotation interface because the corpus was not annotated beforehand, so we relied on the submissions of the participants to do the annotations. We would judge, all the participants would judge the annotations of all participants. And there was also a live leaderboard on a 1/5 of the test set, which was updated daily, and so every time a participant would submit, he could see the performance of his run and the relative performance to other run. You would know that you are worse than another run, but don't know by how much. The idea would be to encourage participants to submit again and again to see how it goes. So we had 6 participants from all over the world, and the one in bold are the one who could make it to the workshop. So as you can see, we have people from nearly all continents. No, it's not completely true. And so here are the results. So the main result is this one. So we have the team UMC who won by a relatively small margin compared to the Motif team. So these results were obtained on the 4/5 of the test set with 600 queries. And you can see also the 3 baselines in this slide to get an idea of how things went. And surprisingly, the best results as baseline is concerned, were for the visual approach only. And here is another ranking based only on queries for which people appear in at least 2 videos, so reoccurring persons. So basically this is the same ranking except the performance is a bit worse. And then just a few words on the tested approach. So the first family of approach was first doing speech turn or face clustering and then try to propagate the names to the clusters. Another kind of approach was first tagging specific shots and use those tags to do pseudo-supervised recognition afterwards. Then there would be fusion at decision or score level. Another family of approach by one participant was to model this problem as a, 5 minutes, was to model the problem as a graph-based tag propagation problem. The winning team also used talking face detection that would help in this task where we really wanted to have talking faces only in the results. And unfortunately, nobody used a speech transcript because that was also what we noticed last year. And with this very diverse corpus that we provided this year. We expected participants to use speech transcript, but it's not the case because I mean it's much more difficult to first get the names from the speech transcript and then to actually use them to tag the speakers. So just to summarize, the winning team used this kind of approach. So first clustering speech tone and face and tagging the clusters, followed by fusion and talking face detection. The second team used this kind of approach, joint multimodal clustering and tagging with graph-based type propagation. You'll know more about this approach later in their talk. And the third team used the other kind of approach, like tagging specific shots and then try to use them for supervised recognition. And I also plot this curve because, as I was saying, we asked participants to participate to the collaborative annotation of the corpus. So we'd like to thank all the participants who gave some time to make the annotation better. And just a final word, which has nothing to do with this, at least, yes it does. We just have a project starting about unsupervised character recognition in movies and TV series. So we're hiring postdoc, PhD student and a master student internship. So please drop me an email or come and see me directly if you're interested. And I just want to finally acknowledge those projects and partners. So on the left you have the ANR funded project, Chamomile and Metala TV. And on the right, these are participants and other partners who provided the task with either corporas or actual baseline modules. So thanks to them, in particular the UMC project and UPC people. Thank you. I'm done.